There we go. Okay, so thank you for joining us, guys. We will go over some solar basics today. You are very welcome to use the group chat if there's a question or a clarification that you might want, um, something that you might want elaborated on or whatnot. Feel free to drop it in the chat, and that way, as I get to certain stopping points, I'll go ahead and address those questions in the chat. Just to try to minimize a little bit on the interruptions. But again, I try to be cognizant of stopping every couple of slides and asking if anyone has any questions or needs clarification on anything. And that said, we'll go ahead and get started. My name is Ernesto Vasquez. A lot of our clients and most of our team members just call me Junior. Whichever's easier for you, I respond just as happily to either. And today we're going to be going over some general concepts regarding the deployment of solar power, some of the configurations that we offer, some use cases, and some tips for successful deployment. And then we'll go ahead and finish off with a question and answer session. So, solar panels. And I do apologize. I'm sure that we have a wide variance of experience here in terms of, some of you guys know this stuff like the back of your hand, and some of you may have never done this before. So I do apologize that I'm going to start off like very basic, but I promise that I will be brief so we can get into some of the more advanced and more interesting concepts. But for the most part, solar panels, they're usually made from silicon or other semiconductor material, but usually silicon, and it's installed in a metal frame with a glass casing. When this material is exposed to the sun's energy, it releases electrons, produces an electric charge. That electric charge gets carried through our wiring and stored at a DC. This DC electricity rather gets stored in a battery, and then a very critical portion of any well-designed solar power system is that it includes an MPPT controller. That thing is crucial because that is what is going to intervene between the panel's power output versus what the battery is getting in terms of energy. And this is very important because if you know anything about battery life and battery mechanic, like how to maintain the longest battery life possible and how to make sure your batteries are healthy, it's very important that the energy curve through the charging cycle is optimized. And to make that explanation as short as possible, just like your cell phone batteries, lithium ion, lead, which by the way, we use lithium ion. We'll get into that a little bit later. But in any case, most of those modern battery types will have a different range of what voltage and what current is actually optimal depending on where in its battery capacity cycle is. So just for example, maybe from 0 to 20 or 30%, the ideal voltage is such with such current. And then once you get to that 20, 30 to the 70, 80 range, there's another voltage and current that's appropriate. And then at the top of that range, there's a third. So the idea is that MPPT controller is always making sure that it's giving the best voltage and current possible to that battery to make sure that it's not only charging as fast as possible in the context of a healthy pace, but that again, the battery is not being overloaded or underloaded at any of those times where it's necessary to adjust for the part in the charging cycle that it's currently at. So again, thinking about the battery here, the batteries are measured in amp hours, right? So a quick back of the napkin formula you can go with is that a 10 amp hour battery should be able to supply 10 amps of current for 1 hour, or inversely 1 amp of electricity for 10 hours. And the main takeaway here is that the higher the amp hour rating on your battery, the longer that you'll be able to power devices without needing to recharge. So just to give a real world example of how some of these numbers could affect your solar panel deployment, your solar power deployment rather. Taking a typical single IP simple camera, not a PTZ or anything advanced like that. We can say nominally, typically they would consume about 5 watts. With that number, and then taking our voltage and plugging in the formula that gives us our amps, which is our current draw, we know that 5 watts at 12 volts is going to consume 0.42 amps. Once we know that, we can divide our 20 amp hours by that 0.42 number, and we know that we will get approximately 40 hours of runtime off of a 20 amp hour battery, right? So just to flip that and give you a little bit more context with the same battery size, the second example would involve our camera, our typical camera load from the first example, but in this case, we would be adding on a 4G modem, right? So think like a Cradle Point, one of those guys. That represents nominally an 8-watt load. So when you add that 8-watt load to our camera load, we have 13 watts. When we plug that into our formula, we get 1.08 amps, which is considerably more than the 0.42 from our last example, meaning that now when we take our same 20 amp hour battery and divide it by that 1.08 amps, now we have 18.5 hours of runtime as opposed to the 40 that we had in the last example. And really the whole point of this example is just to illustrate that it is critical that you take into consideration any additional loads or the complete load really that you're tagging onto the system, and then even over provisioning a little bit over that, which we'll get into a bit further in a later slide. It is critical that the correct system sizing is ahead of time to make sure that you don't put yourself in a difficult situation by deploying an underpowering system or an overpowered system, right? I mean, you want to get it right. So that being said, finalizing some of this battery talk, we want to make sure we calculate for our total load and that we estimate properly our runtime needs, right? So depending on where you are regionally, you might have 12 versus 16 hours of sunlight. That's something you've got to account for. So again, keeping in with the same math formulas, if we used, if we had a scenario where we required 16 hours of runtime and we had a 20-watt load, we know that we would be consuming or drawing 1.67 amps, which gives us a basically 16 hours of, with the 20-watt load, we'll get exactly 16 hours from the 20, from a 30 amp hour battery, you'll get at least 16 hours because it'll be approximately a 27 amp hour load. Before I go much further, does anyone have any questions at this point? Okay. And I don't see anything going on in that chat box either. Perfect. Okay. So we'll keep going. Some factors that could very well impact the efficiency and overall performance of your solar deployment. As I touched upon a second ago, regional variations in sunlight availability will definitely affect how much energy that panel is going to be able to generate for you on a daily basis. So while here in sunny South Florida, we might get 5-6 peak hours of sunlight daily for a very good percentage of the year, some of you guys up north might be, not as lucky in that regard, in that department, and may only be getting 3 to 4 peak sun hours daily, and that's on a much more seasonal pattern than we experience down here. So that's something that you're obviously going to want to account for. And then in general, whether you're in a north or south, you're gonna want to obviously try to avoid any shade that might be produced from any nearby structures or trees or anything like that. You want as much direct, uninterrupted sunlight hitting that surface of the panel as possible. And another general tip is you want that panel to be facing the equator as much as possible. So what that means is the basic rule of thumb is if you are in the southern hemisphere, maybe you're in Brazil doing a project, you want to make sure that you are placing the panels on north facing surfaces. And inversely, if you're up here with us in the northern hemisphere, you're going to want to primarily mount the panels on south-facing surfaces. And there's also some tips that I don't think I included because I thought they were maybe a little bit advanced and maybe a little bit outside of this, but for the sake of discussion, you're also, so as far as the tilt angle, you're supposed to try to emulate your closest latitude line. Right? So if you're closest to like 34 latitude, then you would try to get a 34-degree tilt towards the equator. That's a little advanced though. We can talk about that on one-on-one sessions. Other things that could affect the performance or the overall output of your system, funny enough, extreme temperatures, right? As much as these things thrive off of direct sunlight, there is a point where if they become too hot, that'll actually reduce the power output a little bit. It's not hugely critical. And in most cases, you are going to be mounting this where there's going to be a decent breeze or there's going to be, seasonal changes and things like that. But to be fair, if you are mounting these things on a out in the desert or something, you might want to consider pointing a couple of fans at it or something to that effect, because overheating can reduce your efficiency. Absolutely. And it's also important, critical, that you match, of course, your load for, in other words, match your power output and your battery capacity for the load that you expect to be able to sustain, right? And this is where I had touched upon a little bit earlier that you're always going to want to, like over provision by a certain amount. Just like, I don't know, quick example, if somebody told you had a gigabit network connection, it wouldn't be wise to put a whole gigabit worth, a total of load on that. You usually want to leave 20-30% headroom, right? So it's kind of the same thing applies here. For example, if you have a 20-watt surveillance, a few cameras that equal up to 20 watts, and you have a 10-watt modem for a 30-watt total, you might want to go a little bit past that and say calculate it at a 40-watt load to make sure that you're accounting for any losses or degradation of any materials over time. I mean, remember, these things are not, you don't expect this to be out there for 1 or 2 years, right? I mean, these things are they're gonna be out there for a while, and we're gonna get into that too, because I'm so happy that we were able to get these in with lithium-ion batteries, because apparently a lot of our competitors are still putting these systems together with lead-acid batteries, and those tend to last about half, and sometimes a little bit less than half as long. So if we're gonna have these things mounted out somewhere for 10 years, you're going to want to make sure you over provision a little bit, because of course over time electronics start to lose their efficiency, power supplies drop a certain percentage of performance. It's just the degradation of the internal components. That's just physics. But yeah, to get past that point, you always want to over provision a little bit. Excuse me. Now, I have intentionally chosen to keep showing these loose batteries and panels and MPPT controllers, because I from my perspective, that's what most of us have been used to seeing for the last few years if we're dabbling in solar power, right? So we're already used to having to like interconnect all this stuff and find a big housing to put it all in, and make sure you have enough room in there or whatnot. One of the things that makes our offerings particularly unique is the all-in-one design that we have employed here. So if you look to your to the bottom left of my screen, hopefully on your screen, you will be able to see that what we have is the entire panel, battery, and MPPT assembly all encased in one easy to mount system with its breakout cables that you would be able to connect direct. That breakout cable, we include an adapter that gives you a 2.1 millimeter standard, center positive DC plug, the kind that you would use to power most 12-volt devices in our field. I don't think if I have here this kind of plug. I'm sure we're all familiar. That's probably hard to see on there, but yeah, we make it super easy for you to have a very easy to install, easy to maintain, and very aesthetically pleasing convergence of these three, basically four, if you think about the mounting hardware as separate. We take all these components and we put them in one nice aesthetic and easy to maneuver kit. And in addition, these batteries that you see that are part of our panels are also removable, right? So you can, if you need to service one, or if it's like a critical application where they want to have spare battery banks ready to go, so that like you can just hot swap and cause minimal disruptions to the power supplies that are, the devices that are being powered. You can take advantage of these modular replaceable batteries to be able to service some of those situations. Again, for example, you might have a security company pre-charging spare batteries and swapping them on site during particularly cloudy weeks. And something else that is worth noting with our systems is that with our SPS 10050, which is our flagship panel, which we'll get into more in depth in the next few slides, that we are able to unify up to 4 of those panels by using our SPS box peripheral. This box, if you see here on the right, there's a close-up of the internals, and that has an integrated another form of controller that is taking in the power outputs of 1, 2, 3, or 4 of our panels, putting them into, processing them, and then from there, it's actually giving you not only the 12-volt output that the panels themselves were capable of giving you, but you also have the added benefit of a DC, a 12-volt DC to 24-volt DC up converter, which is nice because that means you can also power your Ubiquiti radios or some of these other wireless bridge devices that operate on 24 volts. And in any case, if you're not using the box to expand past one panel, we also have additional small peripheral adapters that you can use to up convert to 24 for those wireless bridge powering scenarios. Does anybody have any questions right now that they would like answered? Anything that maybe I went through too fast and would like clarified? If not, we can always do that at the end on the Q&A. Right on. And one thing to note before I move on is that it's also this multi-panel configuration option also allows you to scale your clients' projects as they grow, right? So maybe the project that they're bringing you in on now only requires 1 or 2 cameras monitoring this hard to power parking lot, let's say, but they know that over the next year or 2, they want to add more. Okay, perfect. They can start with 1 panel now, and they can grow their system as necessity dictates. Okay, so as far as the individual panels that we're offering right now, there's 3 main configurations that we're working with. we have our SPS 8060, which is an 80-watt solar panel paired with a 60 amp hour battery and, of course, the MPPT controller. This configuration will support up to a 20-watt load. We like to recommend this configuration typically for single camera surveillance setups. Maybe you're recording onto an SD card locally, for example. Maybe an access control reader or two if they're, relatively low power consumption. And we've actually had a few instances of clients coming to us to use these in applications for like low power signage, as well as low power lighting, like landscape lighting or accent lighting in the exterior areas of the property. Us then moving up one level from the 8060, we have our SPS 10050. That's a 100-watt solar panel paired with a 50 amp hour battery and PPT controller. This configuration allows us to sustain up to 40-watt loads, and we would more typically recommend this for 2-camera scenarios where you might also have a wireless Ubiquiti, ingenious peripheral, or maybe one of those cradle point 4G LTE devices, or some beefier landscape lighting or signage. And we would typically see this kind of setup used maybe when someone's monitoring like a small parking lot and just needs to have that wireless signal sent back to the main location, either through 4G or through point-to-point, as those Ubiquities are referred to. And then last but not least, we have our big boy here, the SPS 200-100. This is a 200-watt solar panel paired with a 100 amp hour battery. This thing is a monster, and it feels like it too. I've thrown my back out a couple of times just moving this thing around here. It's ridiculous. MPPT controller, built-in 80-watt load max. That is insane. So we typically would recommend this for multi-camera setups. All kinds of signage can be powered with this. Or us basically running both surveillance and lighting or signage. I mean, at that point, you've got a lot of energy that you can distribute. And where you would more typically see something like this being deployed is in like a large outdoor commercial space, for example, that has multiple devices. Think like those police towers with the cameras and the sirens and the microphones. So yeah, that pretty much covers our 3 main current units. If you have any of if you have purchased these in the past and you're not recognizing these model numbers, it's because we did, careful with the wording here, we did replace 2 of the older models with 2 more current models that have slightly different part numbers. But if you have the SPS 10036, for example, rest assured that you can also take advantage of the SPS box to unite up to 4 of those panels as well. I don't want to worry anybody that saw this and said like, oh no, my panel can't do that. If you have the SPS 10036, you can absolutely do that. So last here in our slides regarding our actual offerings, this is the SPS box that I had mentioned a little bit earlier. This is the power distribution hub that will integrate up to 4 ECL SPS 10050s or SPS 10036s. And as mentioned, these are primarily used to expand systems to be able to handle higher loads or for increased redundancy in mission critical applications. And of course, something like this would be typical in a facility where a lot of uninterrupted power is going to be used for multiple uses. Throwing 4 of those 10050s on there, that's going to generate crazy amount of battery storage. From there, we will move on to just a handful of tips that I recommend for you to have success in your deployments of these types of systems. One, it is important that we account for efficiency losses. And as alluded to earlier, you know, lead acid batteries typically provide a usable capacity of 50-70% of their rating. I must have left out the part on lithium ion because I don't see it here. But with lithium ion, it's similar. They have a little bit more of a range. I think it was like from 30 to 80 or something like that. I'm sorry, higher usable capacity, 80 to 90% of their rating. But in either battery style, you do lose a bit of efficiency in the wiring and power conversions that you might want to factor at about a 5 to 15% loss, which brings us to a real world adjustment of some of the same numbers that we discussed earlier, which are like 20-25% increase, which is why the recommendation here, for example, would be if you had an application that calls for 500 watt hours of power, that you might as well size the system for 600 to 700 watts, which again is about 20-25% over. Other things to consider, again, your peak sun hours. A place like Arizona is going to get a lot of that. A place like New York is not. So you want to make sure that if you are somewhere that has less sun and less of it throughout the year, that you want to oversize the panel. So, you know, you might want to consider upgrading to that next level up. And then battery maintenance and life cycle considerations. Again, you know, battery technology has improved a lot in the last 10, 15, 20 years. Absolutely. But still has certain caveats that you would want to make sure that you are respecting if you want to ensure that you are not causing your storage systems to prematurely malfunction or just fail altogether, because you know, you'll have them doing things that they're not meant to do. So that being said, like I alluded to earlier, the lithium ion batteries that we use in our system are typically rated to last 5 to 10 years, as opposed to the typical lead acid batteries that were being used for these purposes. And those would typically last 3 to 5 years. How do we make sure that we keep the battery at the higher end of that lifespan? Well, we want to avoid deep discharges as often as possible, or as much as possible. In other words, in an ideal configuration, the interplay between the stored energy in the battery versus your load will always be able to provide enough charging versus consuming that battery is never really going to go under 50%. I mean, that would just be ideal, right? Of course, there's going to be situations where that's not going to happen, and you're actually going to end up dropping to 40% regularly, 30% regularly, 20%. As you can imagine, it's a spectrum. So as you get further and further away from that 50% on the low side, you may be stressing out those batteries more than is recommended. So try to keep that in mind. Again, that's a good case for over provisioning a little bit just in case. And with that being said, if you are taking advantage of the modular, removable nature of the batteries, you want to make sure that the batteries that you are keeping as spares, that they are being kept in a cool, dry place and very much outside of the of direct sunlight being able to hit it in any way. Now, before we move on to the Q&A. One of the last things I want to make sure you guys are aware of is that we are absolutely here for you to assist you with these projects. Not only do we have a 3-year warranty that'll cover any manufacturing defects or premature failures, but we have a team here of incredibly intelligent and also very personable technicians who have been with us forever and will happily assist you with sizing your solar solution. And we provide this as a courtesy to our customers. This is not something we charge a fee for.
Inglês disponível. This toy.
And last but not least, our panels are expandable, meaning that you will be able to start with one and add more as needed to be able to keep pace with your customers' demands, energy demand. So if you made it this far, congratulations. You are now eligible for a 5% discount on your next order, as long as it contains at least one solar panel. And this offer is good until the end of the day on April 29th of this year. So I want to make sure that you guys absolutely take advantage of that. And that's it. That's pretty much what I had prepared for you guys, but I am more than welcome to answer any questions or go over any scenarios that you guys might currently be dealing with that you can use some advice with. Okay, I'm gonna quick look in the chat here to see if so somebody's asking what happened with PoE devices. Okay, I'm actually glad you asked. We do have some peripherals that I can show you here. So for PoE, what we okay, we actually have multiple ways of handling that. Excuse me. With we have, first of all, depending on the situation, which device it calls for, we offer a 5-port, what's the word I'm looking for? Industrialized, ruggedized, little PoE switch that is outdoor rated. And we also carry a passive PoE injector that you can tie in with the system as well. So, for example, if it's just one device that you're trying to power through PoE, as opposed to multiple, where the switch would be more appropriate. Somebody asked, does adding more panels to SPS box provide more power output? It does not. So that's a great question. Adding more panels does not, you're still gonna have your 40-watt load maximum when you expand, but when you make that expansion, you are basically not doubling, but you are proportionally increasing your storage, your amp hours by that much. And you are also increasing very much the recharge factor, right? Because now you have 2 or 3 or 4 panels generating power going to the battery. So there's still that I don't want to say a bottleneck, but there is still that limitation of the SPS box internals not being able to boost more than 40 watts, but those 40 watts will be available for a lot longer runtime because of the additional storage, and you will recover the charge on those batteries much faster because of the additional panels picking up additional sunlight and producing additional energy. You're very welcome. Can I explain how to calculate load to system again? Sure. So basically, it's just like division and or multiplying, depending on how you look at it. Basically, you're taking so you got to remember, like everything else that we do in our field, a lot of this stuff is not exactly written in some kind of hard-coded, best procedures manual. You kind of have to make some decisions sometimes. For example, in this case, I would argue that depending on who you talk to and how pessimistic or optimistic they might be. Some people will use the nominal consumption of a device um, to make these calculations, and other people like me, to be honest, because I'm a little bit more like I don't want to say paranoid, but I like to make sure that I have my bases absolutely covered. So I will actually go by the maximum, or at least close to the maximum consumption of a reported device. How does that come into play in the real world? Well, if I'm connecting a PTZ camera, right, to a solar panel or solar power array, that PTZ on paper is going to tell me that it consumes, I don't know, 15, 20 watts, right? That's the max load. But that's the max load, meaning like the infrareds are on, the motor on the PTZ is going because somebody's actively moving it at that time. You know what I mean? Like it implies certain things happening that if obviously in your application might not be the case, right? So if I know that I am putting a PTZ on a solar array, but I know that I am not leaving it set up with with like an automatic tour, and I didn't leave it like set up for auto tracking in some heavily foot trafficked area, then I can make a decent guess at saying, okay, my load is probably not going to be at the maximum. I could probably get away with somewhere in between that nominal and maximum load. But to not harp too much on that particular part of the equation, um, first you determine if you feel more comfortable going by the nominal load or by the maximum load, whichever of those two you decide to go to. And again, this is information that you would be sourcing basically from whatever spec sheet, whatever documentation you have for whichever products you're going to be loading up the solar array with. So if you have a cradle point router, I know we use the example here of 8 watts, but you have to make sure that you look for your specific model and see what what cradle point's documentation says. So if it says 12 watts, then you know that you can come back to the formula and say, okay, if it's 12 watts and I divide that by 12 volts, that's basically 1 amp, right? So that means with our 20 amp hour battery, we're going to be able to power that 1 amp device or load for 20 hours, right? Or if we had 20 of those loads, we know that we would only be able to do it for 1 hour because of our the way that the math ends up equating. So long story short, what you need to know is the amount of watts that you're going to be consuming, right? Which is the total of whatever cameras, whatever radio, whatever devices, period, are going onto that load. All of those watts have to be accounted for. Once you have that number, you divide it by 12 volts, and that's what gives you your amps, which is the current, like your actual electricity flow. And that is the number. Now, once you have those amps, you divide your battery's capacity, let's say 20 amp hours again, by that draw, which we said was 1 amp. And that's how we get our 20. We know that we're going to sustain that load for 20 hours with that configuration. Can you explain with the SPS box, can it handle different type of solar panel or have to be the same? Well, again, the SPS box just works with our 10050 and or 10036 panel. But for what it's worth, across those two models, you can absolutely mix or attach both models, combinations thereof, to the SPS box. It does support both of those models. What are the model numbers of the PoE devices that you offer? If you're referring to those peripherals and add-ons that I just mentioned in the last few minutes, I want to say that the injector, they all start with SPS, right? So it'll be like a ECL-SPS INJ was for the injector. The switch, I'm surprised I actually remember this stuff, to be honest. The switch is ECL-SPS SW5. And we also have one or two other small like adapters and little power. Oh, we have the SPS 12 VDC5, which is the that up converter to get from 12 volts DC up to 24. Um, I'll tell you what, you're more than welcome to email me and remind me that you want to know more about those specific peripherals, and I will send you some links and or whatever other info I have that might be helpful. What I'm looking for now is where I can. Here we go. I'm gonna drop my email in here for you guys in case you don't already have it. That way, if you guys think of any questions after the fact, um, any products like that that you clarified, anything I can help you with at all. I should even have a recording of this meeting available at some point later that you guys are more than welcome to that I'll be more than happy to send you guys. You just gotta let me know or let your sales rep know that you want it. And you are welcome. I'm glad to try to answer all of you guys' questions. I'm just scrolling back up a bit to make sure I didn't miss anyone. Okay, we have a new one. Adding these accessories, will they drain extra power? Yes, yes. And depending on which accessory, that load is going to either be very insignificant. For example, the up converter to go from 12 volts to 24 volts is just like a couple of filters. I don't think it's particularly I mean, that's not fair. It is active to some certain degree, but the power consumption is minimal. Um, Obviously, something like the PoE injector or the PoE switch could consume more, but that's also going to depend on the device that you're connecting to it and how much of a load that represents to the PoE circuit. But in all transparency, yes, absolutely. Anytime that you're like converting from 12 volts to 24 or to 48 or, whatever the PoE voltage that's appropriate for your situation, 54, whatever it is, you're going to see you're going to see variations in how much in how much load is going to be there. But yes, to the short answer is each accessory will represent an additional load. Most of them, for the most part, are going to be negligible. But yeah, those are things that you have to consider specific to the application. And of course, you can always ask us for advice on that. So now someone's asking, when you have 12 and 24 volt devices, is it better to use 24 volt panels and down convert to 12? Well, if that's just a general question, I'll circle back and field it anyway. But just to clarify, with our panels, you're always going to have a 12 volt DC output. It's the 24 that you would need to up convert to if you needed it, or use the SPS box if that was more appropriate for that situation. But to answer your question in general, I would argue it's always going to be better if you have whatever voltage you want to use coming natively out of your panel versus running it through any kind of converter or adapter, only because that does represent, even if it's significant, it is more load. And B, you're also now adding another possible point of failure, right? Like now there's another device in there that could die on you because of heat or because of manufacturer defect or whatever reason. So if it were me, if I had the choice between the panel giving me the 24 volts versus me having to use some kind of an adapter or converter, I'm using the panel with the native output. Is there any accessory to fix the panel to a pole? Oh man, I'm so glad you asked that. And I sincerely apologize that I did not make it more obvious in these slides. Oh man, I apologize for that. Hold on. Let me see if I can make it up to you very quickly here. Does this show the mounting options? No. So absolutely, each one of these configurations that you saw today, they absolutely have different mounting options. Here we go. So for example, the 8060 has, okay, so I apologize that this is not the greatest presentation, but I want to make sure you guys get the information, right? So this is literally pictures that I have saved of the 8060, and what you're seeing here, let me see if I can make this a little bit larger. So here we go. This is the actual contents that are included in the packaging, right? So between these U-shaped bolts and the O-rings, I don't think they're called O-rings, the straps, the metal straps. Between those, you have several different pole sizes that you'll be able to adapt to. And just for the sake of conversation, since we already have this on the screen, this small Ziploc bag or whatnot that you see on the right hand side, that's actually the adapter I was referring to that would have your 12 volt 2.1 millimeter plug. That's right there on that guy. And similarly, and I'm not gonna make you guys look at pictures of all of them, but just to keep on with that example, if I go to the 10050, you'll also see that, for example, we also include the straps. And if you look up in the upper right hand corner, this I don't know, sandwich kind of design is what will basically hug the pole so that you can go ahead and attach this neck piece all the way that's on the bottom right to that, and then that connects to the back of the panel, and voila, you have your pole mounting. So thank you so much for asking that, because that is an important detail. We absolutely have pole mounting options. Let's see, what else? Okay, so if anybody has any other questions or anything, can you change the angle of the panel if needed? Absolutely. So in that same, what's the easiest way to show you? Okay, so for example, this is the back of the 10050. In this view, you don't see any of the mounting options attached, but if you notice this hub, this joint here at the bottom of the panel, if you look closely, and I'll do my best to zoom in here so you guys can see how there's like a series of teeth, like it almost looks like a gear. That's important because when you attach that to, okay, so that's a different angle. You can see much more clearly there the teeth and the gear type, the gear-like structure of it. When you pair that with this, the neck piece that I was referring to here on the bottom right, you'll notice it also has a similar configuration of teeth and like gear-like interface. That joint is what allows you to, as finely spaced as you see those teeth, that's how precise you can make your tilt adjustments on that panel. So yes, absolutely, you can change the tilt angle on the 10050. The 8060 has a similar, if I'm not mistaken, kind of let's see how on this one I may have to confirm for you guys. but I was under the impression that all of them had tilt. I'll find out. Give me 1 second. Okay, so that's a very good question, and I will absolutely be getting confirmation on that now. But we know that I know for sure that the 10050 has it. I mean, that's like our flagship model, so that's the one that I end up experimenting with the most. But I am getting confirmation on that now. This is the SPS 200/100, the big boy. Okay, so I did get confirmation that the 8060, the smaller one, does have tilt angle adjustment. I think it's this larger one that is relatively static. So for you to be able to adjust or account for that tilt angle, right? Okay, so there's the confirmation. Yeah, the 200/100 is fixed. So you would have to account for that tilt angle, obviously by making sure that you mount this at an appropriate angle. You might need to use some shims or some kind of a custom little bracket or something. But the good thing is that the way that it is mounted on the bracket is pretty much like a good sweet spot where if you absolutely had to mount it that way, I mean, that's pretty much like the standard general recommendation. If you're not gonna pull out a sun dial optimizer and get to that level of specificity. But also a great question, man. You guys are really doing a good job of reminding me of to cover things that are definitely worth covering. And I apologize, I actually didn't include some of this stuff in the presentation. Oh, thank you. I appreciate the kind words. I do. I do. Okay. If anybody else has any, oh, here we go. When mounting more than one of the SPS 10050 in the same array and on the same pole, what is the recommended height difference between each solar panel? Wow, that is an excellent question. And I am going to postulate that it's probably just enough of the height to make sure that you're not casting shadows onto one panel from the other. But I'm also going to consult with somebody smarter than me to make sure that I am not under informing you guys. But again, let's see if I got close. I don't see any reason related to like heat dissipation or electromagnetic interference or any of the other typical scenarios I could think of where it's recommended to create a certain distance. So I would like to say that it's really just going to be based on making sure that you're not casting shadows. But I will be able to get confirmation on that any moment now. No, okay, right. Yeah, what I got was that there is no inherent distance recommendations, which again, just make sure that you're not casting shadows on that bottom panel from the panel that's mounted above it. Junior, will you be redoing this presentation on some other day as well, as I was not able to view the whole presentation? I'll tell you what, we absolutely recorded, or at least I initiated the recording of this webinar when it began, and I will be very happy to share that with anyone and everyone. As a matter of fact, if you joined late, I'll go ahead and drop my email address again in here. You guys feel free to email me or ask your sales rep for a recording. And if you go through that recording and you still have answers or you still have questions, please email me. If I get more than like 3 emails like that, I will gladly set up another session next Wednesday for just you guys that missed it. You have my email address anyway. I'll be more, you could just ask me directly for any questions or clarifications you need. We are here for you 100%. If I don't know the answer, as you can see, I have geniuses here that can always jump in and save us. So take advantage of it. We're here to help you guys from A to Z. That's funny. I just got the follow-up comment like, well, yeah, of course, you want to make sure that you don't cast a shadow. Fair enough. Perfect. All right, nailed that one. But yeah, um, I'll be more than happy to produce the recording. I'll be more than happy to fill in whatever gaps one-on-one with you guys. We could even jump in a Zoom meeting one-on-one, and I'll share my screen and go over whatever concepts. Take advantage. We hope to be your most valuable resource in this in this field of uncertainty, right? So please take advantage of us. I mean, take advantage of the resources that we happily offer. And again, I really want to applaud you guys for not interrupting in any significant way. That was awesome, especially for a crowd this size. And B, for asking very well thought out questions. Great questions. When will this recording be available? That depends on the Zoom cloud thing, but usually I want to say it's within an hour or two that I get the email that the recording is ready. So, but don't let that stop you from emailing me and asking for it, or dropping your email here in the chat if you know you want it, because I'll go ahead and the moment it's available, I'll make sure to send that to you. But absolutely, I've never seen it not be available the same day. So latest this afternoon, you'll be getting that recording. And I really, really hope that I started the recording. I definitely meant to. Yeah, okay, looks like we are. I think I see one more question coming in on the private channel. Bear with me for a second. Oh, it's just someone sharing the email addresses to send to. Perfect. Yes, I absolutely got you guys. Just take a quick screenshot here of your email addresses. God forbid I lose the okay. I've got 3 email addresses already that I will be sending the recordings to the moment they become available. And at the risk of being repetitive, I'll say it one more time, and I'll put my email in here one more time. You guys have full access to us. We have Zoom meetings constantly to go over stuff with visual aids and a team here of genuinely tech savvy and guys that just really like talking about this stuff. So yeah, let us know. Let us know how we can help, how we can make your business processes easier, which in turn will make your life easier. Let us know. Otherwise, if nobody else has any other questions, or we'll be dropping in emails in the chat box, I will bid you adieu, as they say. And if you got here late, because of whatever confusion I keep seeing in my peripheral vision, I don't know, apparently there was another link to a different room or something, but I'm glad that you guys made it here, because you guys were great. But yeah, if you were one of those people that made it here late, again, more than happy to share the recording with you. And if there's enough of a demand, which honestly has to just be very little, just 2 or 3 of you tell me that you want another session of like this, and we'll do it. And again, can always do it one-on-one. All right, thank you guys, appreciate you, and hope to see you guys on the next one. We will be making it a point to try to have some kind of an informative webinar like this, at least on a monthly basis. So keep an eye out for those invites, guys. Have a great day, and thank you.